So now we'll get into the application part, the one that, like, why are we learning this, right? And this is why we're learning this. So there are many applications of exponential and logarithm equations, rather. Some problems that involve the applications of logarithm and exponents involve anything that's growth rates of population, radioactive decay, compound interest, pH scale, Richter scale, and so on. So those are just some of the ways that the logarithm and exponential equations are used. So let's take a look at example number 1. So country's population is growing at the rate of 3% annually. Assume that the population now is 30 million. So now it's 30 million. Use the formula, the growth formula here, to answer the following. So on the test, you're going to be given a formula. On the exam, you're going to be given a formula. Okay? So that's going to be a given. Let's do letter A. What does that say? What will the population be in 15 years? So they gave us, let's see this, A, P, E, R, T. So A is the final amount. P is the initial amount, or initial population. You know that's base E. R is the interest rate, the growth rate rather. And then the T is the time. Rate, T is the time. Okay. So the question here is, what will the population be in 15 years? So what are we looking for in here?
We need the P, the R, and we're given the T.
Yeah, we're looking for the A, because now it's 30 million, but we want to know how many, and the population is growing. So how many will there be 15 years from now? So yeah, we're looking for A here. So now it's 30 million.
For these variables, do they have like an SI unit, or can we just be plugging in whatever?
No, it's basically, you're talking about SI unit. Yeah, no, they're all just whatever you see here.
Okay.
Yeah.
So if I were given hours, I would plug that in for my time?
Oh, yeah, for this one here, the time, that would be in years.
Always years.
Yeah, years, yeah.
And my rate is always a percentage.
Mm-hmm. Yeah. So now you go. So is that good? So 30 million is the P. The E is your base E. And then R is 3%, so 0.03. Time is 15 years. Okay. So now the common error is typing in the exponent for E. So if you need to do this all at once, I would suggest that you put a brackets around it. Okay? So when we say E to that exponent, it means the whole part of the exponent. So I'll give you a chance to type that in, and I'll type it in as well.
And we always convert our percent into decimal?
Mm-hmm.
Because I just did it like 3 times 10 to the 7, and I just kept it as 4.7 times 10 to the 7. Is that
Oh, you put it in 4.7 times 10 to the 7. I'd say you just write it down. Yeah.
Will be any significant figures in math, or are they just too outlandish for
No, I
calculation?
think it's just basically just the way it is right now. Like in standard form. So everybody got 47 million, right? Okay, good. Everyone's good, just looking around. Okay, if you're still typing, I'll wait. Yeah? Okay, good. So now let's take a look at letter B. How long will it take for the population to double? Now, how long? What are they talking about? Time. So how long? If it's a measure of time. How long will it take for the population to double? Okay, well, what do we know? We know the P is 30 million. The rate is 3%. What else do we know? The final amount must be 60 million, right? Okay, so this is how it's going to be. A equals to P, E, R, T. We're solving for T. How long will the population going to be doubling? So it's now going to be 60 million here. E equals to 30 million times E to the R, 0.03 T. So far so good?
Move it to the front.
Yeah. So what we're gonna do is, well, the E is the base for this exponent, right? And then this 30 million is just multiplied with that. So what we could do, it's a possibility. Yeah, we can divide by 30. Okay, remember earlier we let me see that question. Remember this question earlier? So we were able to divide by 5 to make it 40, smaller. So we're gonna do the same thing. So if we divide by 30 million, that is 30 million. So this is gone, this is gone, this is just 2. So we don't have to worry about carrying all of these millions. Okay, so far so good. Okay, what do you think we should do next? Natural log, okay. It makes sense for us to do a natural log because this is base E, right? So let's do natural log. So ln 2 ln E to the 0.03t. Okay, so you can see I'm showing every single step. And then I'm gonna take that, move it to the front, so it's still natural log of 2, 0.03t, natural log of E. Okay, well, now what happens? Now, natural log of E is equal to 1, right? So, what exponent for E do I need to make E? Well, just 1. So this is going to be natural log of 2 equals to 0.03 times 1. Oh, I forgot the t. Okay? So just for the sake of the people who are not present today, they know what happened. Now, how do you solve for t? Divided by 0.03, 0.03. So that becomes t is equal to 23. let's go 105 years. So that we're getting used to the 3 decimal places in preparation for the provincial exam. Okay, so it's going to take 23.105 years. Now let's just double check. Let's see. 30 million. 30 million. Okay, times E to 0.03 times 23.105. Yeah, it's about 60 million, right? And it's not gonna be exact because this is not exact. We rounded it off. Okay. Good. Now letter C. What assumptions are we making in here?
That it will continuously go at 3% annually.
Yeah, that's right. So we're assuming that the growth rate will stay at 3%. Right? Because sometimes growth rate is 3%, sometimes more or less. Okay. So this is just projecting. How's that one feel? It's okay? Yeah. Question C. Yeah. Yeah. So they're saying that what assumptions we're making, we are assuming that, well, no, this is not an assumption, right? Because they say it's 30 million, right? But it's not going to be exactly 30 million, but approximately 30 million. That's not an assumption. That's probably a fact, right? They know how many people there are. Time, years, it's not an assumption. When you say 15 years, 15 years. So the assumption here is the rate. Because, right, we're assuming that the rate is going to increase 3% each year. Good? C? C? Okay. Yep. Okay, let's go. Do to the two more. I'll give you a little bit of a break. I'll give myself a break. Okay, now here, wasps. So there was a nest with 200 wasps. If the rate of increase of wasp population per day was 0.015, how many days did it take for a wasp population to double? Use the formula. Oh, okay. Now this is what the question that you were asking for earlier, like the rate here is annually, and then this is 15 years. Now this one here
It's asking days.
is asking, this rate is per day, and then they're asking for days. So we'll keep it as days.
So when I
Yeah.
solve for T, it will be in days, no unit
No,
conversion?
yeah, no unit conversion for the,
Whatever like if it's asking for years, the T will be in years. If it's not,
yeah. So they have to agree. So it's like if the rate was per year, then how many days? So your calculation would be years and then convert it to days. Yeah. So they have to agree. If it's days, and everything is days. If it's years, everything is years. So here we go. There was a nest of 200 wasps in. So what are we looking for? How many days? So we're looking for T time, right? So A is equals to PERT. Okay. How many days for the population to double? So to double, it means to make it twice as many. So to double, it means it's going to be 400. Is everybody okay? You want the population to double. So it started here. This is the P. And then this to double, A is going to be 400. Okay. So P is 200, E, R is 0.015, T is the time in days. So again, we'll just divide that by 2 to make it easy for us, right? Divide by 200. Times 2 is equals to E to the power of 0.15 T. You want to pick it up from here? I think you can do it from.
When we do stuff like this, can we keep like the RT written as RT until it comes down to when I need to divide out the actual value of R?
You can. You can. Like,
Like, I haven't plugged in RT.
Or-
Well, I don't know T, but
yeah.
it's
So-
just easier than like writing out all those little decimals and making it more messy.
Sure, yeah. That's okay. You can show it to me when you see something like that. So I know exactly what you're talking about.
And keep it to 3 decimal places.
Yeah, we'll just keep 3 decimal places. Is that okay? And then now that becomes natural log of E is just 1. So natural log of 2 is equals to 0. Sure. Okay. Is that okay? 46 days? No. Okay, is that too fast or you're good? You're good? Now, the other one says, example number 3, it says exponential decay. Do you notice the difference between growth and decay? So example number 3 says radioactive substance is decaying around according to the formula.
Oh, the R is going to be
Negative. Yeah, the R is negative, right? So that means it's getting, instead of being raised to certain power, it's being, well, yeah,
It's for decaying.
it's being decayed, yeah. Okay, so let's see here. How much remains after 3 years? Let's see here. I'm going to read it first. So a radioactive substance is decaying according to the formula. Okay, that where A is the amount of material remaining after T years. So T is years. Okay, and then this is years. So everything is now in years, no longer in days. So A equals to P E negative 0.2 T. Okay, so what do I put in here? How much material remains after 3 years? What am I looking for?
80 grams. This is grams.
Oh yeah, grams. Yeah, that's what it is. Grams, 80 grams.
You're looking for the E. No, so the A.
The A, we're looking for A. Is everybody okay? They said the initial amount is 80 grams, but the R there, grams. So the P is given, The E is going to be given. Well, we know what the E is. The R is given. The time is 3 years, so that's given. So really we're solving for A, right? Makes sense. So A is equals to 80 grams times E to the negative 0.2 times 3. Okay, it's just a matter of putting that into our calculator. So 80 times grams. And now, this is a exponential decay, so you want to make sure that the value gets lower and lower each time. And it did, right? Because it started off with 80. After 3 years, now it's 43 remains. Okay? So, you got your few things that we have to keep in mind. So we want to show the work. I know that it's easy for us to kind of do that on a calculator, but we want to make sure that you're showing the work, because sometimes exam questions, they have 1 mark for showing your work, 1 mark for the final answer, and make sure that we are showing, well, whatever unit we have. Okay? Okay, so I'm gonna pause here. I'll give you a little bit of a break. I'll give you about 5-minute break, and then we'll continue on.
No B?
Oh, I didn't do B. Oh, sorry. I meant, yeah, let's finish the B before we go for a break. Thank you. Determine the half-life. Oh, okay, what does that mean? Have you heard half-life before? You have? Anybody else who... Okay, so half-life, so one person, anybody... This one person, okay, half-life means half is remaining.
For a radioactive.
Okay, for a radioactive substance. So it gets lower and lower, and half-life, determine the half-life of this substance. It means how long will it take to cut it in half each time, right? So, now if it starts with 80, so I'm going to write that down, P is 80. Now, half-life, that means the amount would be half of that, which is now 40 grams. GM. So the rate is still the same, right? R is equals to negative 0.2. But now we wanted to know how many years will it take for that to happen. Okay. You know it's going to be close to 3, because 3 years is about 43, so it's going to be 3 point something years, right? Okay, so yeah, it makes sense. So, but let's figure out the actual time. So A is 40, right? 40 is equals to 80 e to negative 0.2t. Is everybody okay with that? All those substitutions? Yes? Okay. I'm going to divide by 80. Divide by 80. So now 40 divided by 80 is 0.5 is equals to e to the negative 0.2t. Now we're going to do natural log of 0.5, natural log of e to the negative 0.2t. Multiply it down. Natural log of e, and then natural log of e, base e, of course, that's just 1. So that t extra 2. So t is equals to natural log of 0.5 over negative 0.2. Okay, let's see what that number comes up with. 3 point something? Okay, hold on. Okay. Okay, 3.466 years. So about 3.466 years.
Still laughing at GAMS.
You're still here.
Still thinking about those GAMS.
Okay, now we can take a 5-minute break, so just go to the bathroom and then we'll continue on after we get that.